Hey guys, Mr. Decker here. We are back. We are doing the updated code.org Computer Science Discoveries curriculum for 23-24. And we are on lesson 6, working on random numbers. All right. Bubble 1 is a prediction bubble. And let's see what it wants us to do. So it says the code below introduces a new math block, the random number block. Try to predict what will happen when you press the run button. All right. It says write down what you think is going to happen when the run button is clicked, run the code, compare your answers, and click the run button multiple times to see what changes in the drawing each time. Okay. So on line 1, we've got a tomato colored background. Making some tomato soup. All right. Fill with orange. We're going to have ellipses showing up somewhere in this range on X. So somewhere between 200, which is here, and 400, which is over here on the right on our display area. And then 200Y. So it's always going to be somewhere here. And then 50/50 is the size of the ellipse or circle. So when I click run, an orange ellipse, I gotta spell it right, will appear at a random X position between 200 and 400, while the Y position, oh my goodness, stays at 200. Run. So every time I run this, that ellipse is at a random position, but it never leaves this range between 200 and 400, and also never goes above or below 200Y. Simple as that. Continue. Bubble 2. All right. You have a new block in the math drawer. We have a math drawer. Drawing drawer, math drawer. Toolbox, drawing drawer, math drawer. Toolbox, drawing drawer, math drawer. Math drawer, drawing drawer, toolbox. All right. Workspace, instruction space, display area. We getting this? We got this? Okay. If you make your drawings with random numbers, it's going to look a little bit different every time you run your program. Click on the block to read its documentation and learn more about how it works. So the random number block over here. So this is the minimum number and this is the maximum number. That's really what you need to know. And it's just, these are pixels. These values represent pixels. All right, do this. Change the numbers inside the random number so that the ellipse can appear anywhere horizontally on the screen. Okay. Horizontal is left and right. So anywhere, so we'll change this to 0 and leave that at 400. So now it can be over on the left, whereas before it was always over here somewhere on the right. Make sure the ellipse appears both on the right and left side of the screen. So let's keep running it to make sure that is true. And it is. Yes. All right. Let's finish and continue. Random numbers. Here's the same sun from the last time. Right now, the x coordinate is random, but you can make the y coordinate random too. Make the ellipse appear at random y coordinates. So if we go in the math drawer, we grab our random number block, we put that in y position. Now we can do 0 to 400 on this as well. And then when we run our code, now it can appear anywhere within that 0 to 400 on X and 0 to 400 on Y, which means that anywhere in the display area is fair game for where that circle is going to appear. All right. Let's finish and continue. Bubble 4. Variables can be assigned a random number too. This lets you save a single random value so that you can use it as many times as you want in your program. Make the eyes appear at random sizes, okay? So right now, every time I click run, it's the same size at 27. So I can go to my random number drawer in the toolbox, drag out that random number, put it in the value position for the variable label, where we're declaring this variable on line 2. And we can give it a eye size between, let's say, 15 and, let's say, at the biggest, 75. Now, eye size is being used down here on lines 13 and 14. So we've declared the variable, and we're calling that variable for use down here. So now every time I run this, the eyes will be a different color within that range, 15 to 75. All right. Let's see. Update the parameters of the random number block so the eyes appear both small and big. We've done that, I believe. Run it multiple times, verify that the eyes are always the same size and that they always change sizes each time the program is run. Yeah, I think we got it, kids. I think we got it. All right, let's move on. We're trying to move on. There we go, internet. Okay. These two flowers use a single variable to store their petal size, but the value stored in the variable changes in the middle of the program. Let's update the program so that each petal appears with different sizes each time the program is ran. Okay, there's lots of steps here under do this. Update the first flower petals to be a random size. Find the first time the petal size variable is used, right here. Okay. Drag out a random number block into the right size of the petal size variable. So we'll go to the math drawer, random number, update the parameters of the random number block. 1 to 10, what does that do? Oh, that makes them super tiny. So these are the ones we're changing. So I'm trying to remember what worked before. I know it wasn't 50. Maybe 75 to like 95. Let's see. 95 is way too big. Let's try like 65 to 80. Let's try even smaller, 50 to 80. Okay. Running code multiple times. Both flowers should have different petal lengths. Okay, what am I missing? Okay, update the second flower's petals to be a random size. Find the second time the petal size variable is used. Okay, so it's getting updated. Okay, so I understand how this is working now. All right. So right here, we're declaring a variable name, but we haven't given it a value. Right here, we're saying, all right, that variable that we created, remember that back on line 1 computer? That variable value should be 50 to 80 here. It's always static at 60 here. So I need to grab another random number block. And I'm going to do like 40 to 70 on this one. Yeah, there we go. So now they're different each time, both of them are updating. Awesome, that works. Let me just double check, make sure both flowers should have different petal lengths, and they should be different from each other. Okay, that's pretty much what's happening. Yeah, it's very significant here. You can definitely tell it's different. Okay, finish and continue. All right, on bubble 6, we've got a few practice things to work through. Let's modify some planets. That sounds fun. Terraforming. Okay, this scene represents several planets. Right now, they're all the same size. Let's use random numbers to change the size of each planet to generate a new planet scene every time the program is ran. So right now, we're not using any variables. And every time we run it, it looks exactly the same. Okay. So we want to update each planet to be a random size each time the program is ran. So first, we'll have to go to variables and declare one. Declaring a variable means that you want the var x gets blank. If you try to do x gets blank first, it's going to confuse the computer. You got to declare that variable first. All right. So variable, let's name this variable planet size. And it wants it to be random each time. So we're going to go to the math drawer, grab that random number block. It's the name of the whole lesson, so we can't forget that. Random number, let's say between 25 and 90. Let's see what, not 900, but 90. Okay. Update each planet to be a random size. So now we need to use this, Control C, and we're going to have to put that everywhere. I'm just Control Ving it into each of these spots. Reset so I can see the bottom of my code. And that's going to update the width and the height. Oh, but you know what? It's the same every time. See that? I don't want that. So what I'm thinking, let's go back to the instructions. How do they want us to solve this? You update each planet to a random size each time it's ran. So an easy way to do this, we don't need that necessarily. So let's pull this out. And we're going to put a random number. Let's make this as simple as possible. We're only going to have one parameter for size. And we're going to put a random number block in each of these size parameters. And then the biggest one in our solar system is usually the sun, right? And then we're going to go through and give these some random sizes, 10 to 30, 15 to 40, 20 to 50. You see what I'm getting at here. 25 to 60. So I'm increasing the minimum of each planet by 5, and I'm increasing the max of each planet by 10 each time. Cool. Yeah. And the sun should always be the biggest. So I don't want any number on my maximum to be bigger than the minimum of the sun. Perfect. I like the way that looks. All right. Da-da-da is right. Okay. Debug random shape position. Let's do it. All right. So Isaac wrote a program that created 3 rectangles in the same position using a variable x position. I can see that right there. There's the variable x position, gets a value of 100. He tried to update his code to have the rectangles still appear together, but in a random position, but his code doesn't work. Instead, each rectangle appears at a different position. We can fix this code so that the animation appears like the image on the right. So the whole thing's going to move around, but I want it to always look like this ice cream bar flag thing. Right now, it's not working as intended. So if x position is 100, let's see. If we give x position a random number here and then use that variable label down here, that should work, right? So let's do that. So Control C, Control V, Control V, Control V, reset run. Yeah, sweet. And then is it changing on the y-axis at all, or just on x? I feel like I could create another variable, call this y position, give it a random number between, let's say, 50 and 350, and then I could take y position, Control C, and we can up the ante on, oh, why did that do that? What happened? Does this also need to be 0 to 150? Is that my problem? No. Why didn't that work? Hold on just a moment. Okay, never mind. Let's just leave it at this. We'll just use the x position variable. Not sure why the y position wasn't working. If you can figure that out, let me know and share your code. All right, finish. Continue. Bubble 8 or 7 or wherever we are. Yeah, bubble 7 is next. Rainbow snake. Sweet. Alexis is working on a program to draw a rainbow snake that wiggles each time it's ran. She started the program but needs help finishing. Okay. Do this. Run the program several times to see how the starter code works. All right, we've got a wiggling little section of a snake, but we want all these extra colors as well. Add at least 3 new different colored circles to your rainbow snake. Use random number to make the rest of the snake's body move up and down like the first 3. Okay, we can do that. So we're adding 3 more, right? Let's toggle the instructions back in. Yeah, 1, 2, 3, green, blue, and purple. Okay, so what I'm going to do is grab these 3, lasso that, Control C, move my cursor down to the very bottom, Control V. And then change these colors. It was, okay, we got red, orange, and yellow. We need green, blue, purple. So 1, 2, 3, green, blue, and purple down at the bottom. Oh, it'd be great if it would type there. All right, so now it's going to look like a mess because we've got to move these over. So right now the Y position is random, and that's cool. Adding 40, adding 40, adding 40, adding 40, and for the last one, 300, adding 40 to 260. So now, yeah, cool. That was pretty easy. Didn't take long at all. The beauty of copy and paste. Control C, Control V, kids. That's the music in my ears right now. Continue. All right, bubble 8. We should have some challenges. Let's do A, B, C, and D, and then we're out of here, man. All right, random RBG. RGB, sorry, red, green, blue. This level uses RGB blocks to set the color of the rainbow. Since the RGB block uses red, green, blue numerical values, it means that we can use random number to generate random colors. Hint, you're going to need 3 random number blocks to generate 1 color. Okay. So we've got to add a lot of code here to each of these fill blocks. So let's hop to it. Let's go ahead and get started. So go to the math drawer in your toolbox, go to that random number block. We're going to put a random number block in each. Well, let's run this first. Okay, so we're changing the colors of this rainbow. All right. Random number block, random number block, random number block. And we're just going to do this kind of ad nauseum in each of these RGBs for these fills. And they can go 1 to 250, I think. 255, maybe. So for each of these, just change the 10 to 255. All right. Simple enough. Next fill. And we're getting there. It's going to take a minute, but all good things take time. Wouldn't it be cool, though, while we're doing this, we can have some thinky thoughts. Wouldn't it be cool, though, if rainbows actually changed colors instead of just being the regular? And again, whoop, just changing max value. And it's the same max value every time. I hope I read the instructions right. If I didn't, I might be a little bit upset because this takes time. It's a little bit tedious, but when you're coding and you want a specific effect, hit the ground to a random color, we can do that. And each of these should be different every single time you run the program now. Update the background to a random color also. I didn't even see that. It pays to pay attention. First time, every time. Let this be a lesson. All right, so yeah, now we're getting some pretty wacky colors. So every time the ground is a different color, each part of this rainbow is a different color, and the background is a different color. Wow, cool. All right. Finish that one. And let's head over to the butterfly, shall we? Work on some symmetry. All right, so you've learned how to randomize things, but what if you want 2 random shapes to be related in some way? Using a variable and experimenting with the math operations, plus, minus, multiply, and divide. Can you create effects like symmetry in your work? Probably. Butterfly wing patterns are naturally symmetrical. Yeah. This drawing's red spots are placed randomly, but the second spot is always the same distance from the right side of the screen as the first spot is from the left. Try to recreate this effect for a second and third spot. It says read the code to see how the first spot is drawn. So let's see, where is the first spot? What is, we got a yellow. Where's yellow being drawn? Oh, okay, so we've got spot 1 and spot 2 down here. First one, 400 ellipse is 400 minus spot 1. Spot 1 has a value or random. Okay, so it's taking the random number, whatever value it assigns to the random number or to spot 1, it's going to say 400 minus that number to get the other one. So we need a math and a second ellipse block. And this is going to be mathed because it's changing on X. And it'll be a minus 400 minus spot 2. And then these numbers need to be the same, 140Y, size 2020. Hey, beautiful. Perfect. Every time you run the program, it's perfect. All right, finish. And we're on random lines. Bubble 8, see random lines. In the scene below, all it is are just a bunch of straight lines, not very exciting. Let's make the scene more fun by randomizing the positions of each of these lines and have fun while doing it. All right, so let's do this like we picked up some sticks and dropped them. So let's see. Let's see. So for each line, we've got x1, y1, x2, y2. So let's mess with that. It's going to take a lot of random number blocks. Okay, so boom, 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 boom. And we're going to just change the max, 399, 399, 399, 399. All right, how many sticks are there? 1, 2, 3, 4, 5, 6, 7, 8. All right, we're going to take these out. And what I'm going to do is I'm going to Control C that. Let's try to have 10. How about it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, I said. 10. All right. So now the sticks will fall in a jumbled mess. Okay. And now next, I think that's all it wanted us to do, was just randomizing that. So the length changes every time, and the x1, y1 changes every time, and x2, y2 changes every time within that range. I like it. Finish. All right. Where will that put us next? What are we doing now? Random arcs. Let's go. All right, so run it. And it's just static, the same every time. In the scene below, all it is are just a bunch of arcs that look alike. Not very exciting. Let's make this scene more fun by randomizing different properties of these arcs. Do this. Randomize the position and angles of each of the arcs. So let's see. We're just changing the position and angles. So looking at this, we've got X and Y location, width and height, start and stop. Okay. So random number drawer. Location X and Y. Let's do between 25 and 375 for both of these. And then that means that it will appear somewhere within the grid. And then one hundred. Let's go back to it. What is the one? That's width and height. We'll leave width and height the same. And then out here for the start and stop. First, let's make sure that's working. Yeah, they're all showing up in random spots every time. Okay, math, random number, and another random number out here. Let me minimize my screen a little bit so we can see everything. All right, so let's see. It said, I'm trying to remember from before, from an earlier lesson, which direction each one goes. So I think 0 to 360 on both of these, right? And then let's take these out. We're going to copy this. We got 5 of them. Got 5 again. Okay. Yeah, so now we're showing up in random locations, and we've got the random rotations for where it puts the arcs. All right, cool. Position and angles. Yeah, that was it. Finish and continue. And I believe that's it for this lesson. Next thing for you to do would be to choose one of, or do both, the favorite song activity or the favorite season activity down here. And that's it for me. I hope you enjoyed this. I'll see you again for lesson 7.